If you can remember from earlier, division of fractions is just like multiplication, except we do one extra thing. We need to flip the second fraction over before we turn it into a multiplication problem. So it says I can divide and reduce algebraic fractions. And let's start with this first example here. 6 over 10r divided by 9r over 10. We know that that's going to be the same as 6 over 10r, so we write the first one the same way, times 10 over 9r. So we flip that second fraction. And whenever we do that, a multiplication problem is really just one giant simplifying fraction with multiplication on top and bottom. And if we zoom in here, I see that I can start going to work. I have a 10 and a 10 that are going to both cancel out to 1. I have a 6 and a 9 that are not in groups that I can divide both of them by 3. And that's going to leave me with just a 2 on the top. And then I have an r, and a 3 on the bottom. So I have a 3r squared on the bottom. And so that would be my division of fractions. A little bit bigger one here, if we look at number 18. That is a multiplication problem that snuck in there, so watch out for that. Let's try a division one though. So let's try number 20. This one is a nice hairy mess. This first fraction here, because it's division, we're going to keep the same. I'm going to leave myself a little bit of room to expand upwards as I work, because I like to work both up and down with these problems. So we copy that exactly as is. Second one, when we multiply it, we flip the whole fraction. So negative n squared plus 17n minus 70 on the bottom. We have n plus, or goes from the bottom to the top, and then n plus 4 goes from top to bottom. We flip that second fraction when we turn it into multiplication. And when we go from multiplication to a single fraction, we just multiply the top and bottom. But since we have a bunch of addition and subtraction, we need to be real careful about making sure we get all our parentheses represented. So I'm going to put parentheses everywhere on this one. Make sure we are covering our bases. So this very first group here, I see that I have a 5. I'm actually going to change colors just so that I can keep track of things a little neater. Not a bad idea when you're working with these big problems to use multiple colors. I have a 5 and an n in common with everything, and that leaves me with an n left over here. And then 45 divided by 5 is 9, and n divided by n is 1. So I have 5n, n plus 9, and I can get rid of that. Down here I have a 1 in front of my n squared, and this is a trinomial, so I can do my multiplication of two things that multiply to negative 63 and add to positive 2. So I have my negative 63. Ways to get that: I have 1, negative 63, 2 doesn't work, 3, negative 21, 4 doesn't work, 5 doesn't work, 6 doesn't work, 7, and 9 would be negative 63. And in fact, I'm trying to add up to 2, so that's going to work. I just need to flip these signs, and I have a positive 9 and a negative 7. So n minus 7, I go straight to my factors, n plus 9. The n plus 4 down here is as factored as it can get, so I'll leave that. This one here, I do not have a positive 1 in front of n squared, I have a negative 1, so that's going to be an issue. Let's factor that out and make it a positive 1 inside. So I switch all those signs. Next step, I'm looking for two things now, that because I have a trinomial with n equal to 1, I have an a equal to 1, I have two numbers that multiply to 70 and add to negative 17. So 1 and 70, 2 and 35, 3 doesn't work, 4 doesn't work, 5 and 14, that adds up to 19, so I'm getting close. 6 doesn't work, 7 and 10, 7 and 10 is 17, I need them both to be negative. to get negative 17, and now I have my factors, negative 7 and negative 10. So n minus 7, n minus 10. And I keep my negative 1 along for the ride. I can't just throw that out. And finally, I can start canceling things out. So I look from all of the tops to all of the bottoms, and I don't see a n plus 9 anywhere. Oh, I do. Cross these out. I see an n minus 7 group on top and bottom. Cross those out. The 5n seems to be unique. The negative 1 is unique. The n minus 10 is, and so is the n plus 4. So if I were to clean up my final answer here, I've got this, 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 and this. Negative 5n, I multiply the negative 1 and the 5n, negative 5n times n minus 10 all over n plus 4. Again, if you distributed that out and wrote that as your final answer, that may be even better, but I will accept this as your answer. So some of these can take a little while, especially the ones with some hairy factoring. Try not to write too big that you use up all your space, but at the same time, be smart about where you write. Try to write in the center so that you can build upwards and downwards on these problems. It'll make it a lot easier to stay organized. And using multiple colors, if you have some colored pencils available or want to borrow some, is not a bad idea. Good luck.